Presentation, by the way, is more of a pre-sale, if you will, or pre-sale, if you will, of this methodology more than diving deeper into it. As I said, the motivation came from my current employment and how we tackle some of the important aspects of critical infrastructure and its security.
So I'll move forward.
Critical infrastructure exploited. What are we missing, right? We had a very interesting talk by Vivek Ponara today from Nozomi Networks in the morning time. He was talking about, in exactly in this room, he was talking about OT security, understanding some of the gaps, that we should do our cyber hygiene more fundamentally and do it properly, right? It's not out in the heaven that you have to do security to the 9 yards as long as you do your fundamentals properly. So what are we missing in the critical infrastructure space? So many of you who can understand, there are supply chain attacks. There are attacks on our critical infrastructure, whether it is through nation-state actors, whether it is through adversaries out there with geopolitical tensions. We have the Ukraine-Russia war going on right now. You may have heard that Russia has targeted Ukraine's critical infrastructure, literally going after the energy system and electricity sector. So I'll speak about that a little bit on that event which happened in 2015, 2016 in Ukraine, and how Russia actually tried to sabotage their system. So there is certainly something missing here where we are not able to safeguard our systems the way we should, or what are some of our challenges in this space. The Triconic Sys malware. How many of you have heard of this malware, or even in terms of OCS security? Okay. Couple of hands there. So this is one of the malware, or one of the hacking exploits, if you will, which hit the safety instrumented systems of Saudi Aramco. And as Vivek was saying in the morning, and I'll reiterate it again, for executives, it's not important on the ICS side or on the OT side if your data is not available, or if your systems are have a confidentiality problem, if you will. They're more concerned about the safety aspect, the people aspect, the environment aspect, and that's important for them. So when you look at safety systems which instrument and which take care of these critical infrastructure, it's important that there are these malware families which are so targeted, they go after those mission critical functions which are supposed to be working fine, because human life cannot be replaced, and data can be replaced, or its value can be recovered, right? And so that notion of safety versus security, when we talk about IT and OT, we'll come to that, it is critical and important to understand when we move into this world of running commodities, whether it is gas, liquids, electricity sector, etc. We all live here. It is Alberta, right? Imagine a scenario in the middle of winter at minus 30, 35 degrees, if your electrical substation or your whole grid goes down. Those are some very key, very fundamental scenarios which are mission critical, and it could lead to a loss of human life. It could lead to different other aspects. I'm not sure about civil unrest in Canada, but it's important that you take that into consideration. So we have these issues which come up. You have targeted attacks on these systems. Vivek also talked about another malware called Indestroyer or Pipe Dream. So those are some areas where we are missing some way of safeguarding and securing those systems, right? So why this approach, or the approach which I'm going to talk about on cyber sabotage and the CCE methodology? The 5 Ds of sabotage. So if this book talks about those 5 Ds, which actually resonated with me as well, when you talk about sabotage, you talk about disrupt, deny, degrade, destroy, or deceive. Now think for a second and take a step back. Henry Bachman, in one of his S4 conferences, by the way, S4 conference, if you don't know, is very beautiful, a very good conference. You can go on YouTube. It's a very nice conference on looking at OT security. So he said one statement which resonated with me as well. So as Idaho National Lab was doing an assessment with their clients on this particular methodology, a light bulb went out into a CEO's mind, and he goes to Congress and he says a statement. I can go through a disruption of my business activity, but I can't go through a destruction of my OT systems because they're legacy in nature and they will impact my mission critical operations. Take a second to digest that, right? Destroying an equipment so that you cannot provide an important service to society versus disrupting operations, which is also still bad, but you can come back to your legs. The word cyber resiliency, if anybody wants to, think about that in that terms. You're being attacked, but you are still running your operations. So that was important. And is it possible to destroy equipment? Yes, if there are motivated enough nation-state actors and you have ways to do that. And we'll come to that, how this methodology talks about it. So 5 Ds of sabotage, keep that in mind as we move along this presentation. So sometimes people say, related to this particular methodology around consequence-driven cyber-informed engineering, are we replacing our basic information security management? Are we replacing fundamentally our concept of how we look at security? No. For an enterprise, security is, all 9 yards from the IT to the OT side, right? When you talk about basic risk management, you're looking at the whole organization. And then you go up the chain in the pyramid, and then you talk about business risk, more at the C-suite level, more at a sector level, whether you are in the pipeline industry, or whether you're in liquids, or you're in electrical sector, or manufacturing, or water. Then comes at the national security level, where there are certain functions which run our society so importantly that it's hard for us to not look at them and make sure that they don't fail. And that's the important part, which is where I'll talk about this particular methodology on the consequence-driven aspect of it. Another thing, very, very interestingly, Vivek said, if anybody joined that call in the morning, this is an engineering-based approach to looking at how systems work, not a cyber-based approach. This is where cyber will play a role, but it's in the engineering aspects of how things run. So what this whole particular aspect of this slide and what I'm trying to say is, we are looking at certain mission critical functions, whether they are at a national security level, whether they are at a company level, without which either a nation state would lead to a lot of human unrest, societal problems, safety, personal issues, or at a company level, a company may go out of business if it cannot deliver its critical function. And I'll give you an example maybe in subsequent slides, what a critical function actually looks like for an organization. So cyber defenders spend big time and money calculating likelihood of compromise. They're going to get in, get over it. Right? Michael Hayden, former director of CIA. And so this is where I want to again step back and give you an idea of why are we looking at consequences more than on the cyber side. This particular way of looking at things is stating that adversaries would go into your environment. Assume that they are in your environment. Don't spend money, time, and effort trying to prevent them. Not to say that you should not do that. Those are areas where you need to spend your time in the business side to make sure you're not being attacked. But assume you are being breached, your adversaries are in your environment. Now what you will do to come back to operations. Now what you will do to stand back on your legs and say, in the midst of my, of this cyber sabotage or cyber breach, I will keep running my operations. So that's a mind shift. When we look at risk, many of you may know this risk equation. We look at threat actors, adversaries, we look at vulnerabilities, we look at the likelihood of those vulnerabilities being exploited, and we look at the business impact. So what we're stating here is, take it for granted, assume that likelihood of you being compromised or breached is 1, that you will be compromised. Now, from then on, what else can you do to either reduce your business impact or be ready to run your operations in the midst of already being in an adversarial situation? So that's the idea, because there's so much going on in security, you cannot fathom the whole world of cybersecurity. So you are taking a step further and saying, okay, I assume that my adversary on my network. What do I do to try to defend myself? And so this is where we need to understand as organizations or as nation, what is some of our critical functions we are delivering. I'll give you an example for an oil and gas sector. If a pipeline industry or a pipeline company is running operations, they're sending out leakers down the pipeline, they're sending natural gas down the pipeline. What is the critical function they're delivering? They're delivering the critical function of delivering natural gas, for example, to your homes so that you can heat your home. And that's how they make money. What happens behind the scenes are some of the critical functions which enable that natural gas to flow through the pipeline to your homes, from gathering site through the pipeline to the delivery stations. So those critical functions, to quantify them, to document them, to understand them as an organization, or even as a nation state, or even as a province, for example, is important. And what are some of the enabling functions which deliver that critical function? So some of these sectors or some of the pillars out here: infrastructure, people, process, and technologies. I'm sure if many of your students here, when you learn in computer science, they talk about people, process, technology, right? As you look at your strategy, as you build your use cases, always look into that mindset of people. What's my people strength, process, technology. We're including infrastructure in here to give you an idea that these are our fundamental pillars, and they are called enabling functions, which provide a critical function of providing either a fuel to a pump station or to a power station, electricity or liquid pumps, delivering natural gas through the pipeline. So that's an important concept as we go into this idea that you have been breached, bad guys are in your network. What do I do to sustain my critical function? Again, keep in mind, we are not thinking about these critical functions also being impacted and I can still run my operations. No, we are talking about from an executive level at the C-suite, or call it a colonel or a general of an army, when they say, this is some of my functions which has to keep running for my business or for my company or for my army to sustain operations in the field. And I cannot live without them. So I need to find ways to reduce the impact to a point where they keep running and I keep delivering my service. So that's the important aspect. That's where the likelihood aspect goes out. An example of a natural gas system. So what you see here is basically a compressor station. Just an example of a field site where you have a compressor station. What I was trying to show in this, and I'm trying to show in this slide, is the fact that the critical function of any natural gas pipeline, and as an example, is the delivery of natural gas. When you gather it and you give it out to the sites, but in the middle you have valves, you have compressor stations. What is a compressor station, by the way? For those who don't know, gas has the property when it flows, it expands, just like air. When you flow it, it will expand. The molecules expand because as they go along, there's more expansion as the air expands. So you need to keep compressing it. That's the physical formula, right? You need to keep compressing it as you keep sending it down the pipeline towards the end. If you don't compress it, it will become so large that the capacity and the pressure in the air will not be helpful. It's not like liquid. A liquid keeps going in a pipeline with a certain pressure. Gas expands, and so it needs to be compressed. So there are different compressor stations, as they call it, turbines which actually run it. These are turbines what you use in your airplanes, GE turbines. As airplanes run their systems similar to that. So that function happens. And so this is one example of an enabling function, which we as probably a society don't know, or many of you are not familiar to this industry. The end product is we get natural gas in our homes. Finally, at the end, from where it is being generated. So you have critical functions and you have enabling functions. Now imagine a bad guy or an adversary at a nation state level. They go after your enabling functions so that your critical functions cripple. And that's what we are trying to understand here. So if I attack my compressor station, what I showed you last time, and it's a very important compressor station in a section of a pipe, and if that goes down, I cannot deliver gas on the other side. I'll give you an example. In USA, they talk about talking about national security. They're taking use cases out with one electricity sector in Florida. There's some natural gas pipelines too, where they're looking at natural gas being sent to power plants, natural gas fired power plants in Northeast US or in other areas. And imagine if there is one single pipeline, which is an artery providing power to 5 or 6 power plants, and that pipeline goes down in the middle of winter, and your power plants don't get natural gas, they will stop functioning. The ultimate effect is that society will get impacted. People might die in the middle of winter. And so you see the enabling function here is the flow of gas, delivering power, delivering gas to the power plants, which can ultimately provide electricity to the sector. So you see in that those terms how the critical functions and enabling functions play a role at a national security level. And there are various ways TSA, Transportation Security Administration, for those who are in this industry, have certain regulations which have come up. NERC SIP is regulations on the electricity sector. Electricity sector plays a much better role in terms of upping up their game in cybersecurity in this space. But those are some of the areas where there's more focus these days going on. For many of you, show of hands, Colonial Pipeline incident, right? Happened last year. Ransomware even happened on the IT side, but impacted the OT side. But ultimately, it leads to those consequences which are hard to ignore. One other example here is from PHMSA, the Pipeline and Hazardous Materials Safety Administration, and they talk about, they have, if you ever want to go and Google this particular website, they have a website, they have a registry of events which get notified by these operators to them. This is a US regulator, by the way. And so they had a compressor station in West Virginia, and there was an interruption to the electrical power to the station, resulting in loss of instrument and safety air system compressors. Air compressor systems require a manual reset after power loss, but station is unmanned. Inability to maintain sufficient pressurized air volumes to the station resulted in a shutdown of 2 gas compressor units and a partial station shutdown. So what you're seeing here is nothing to do with cyber. What you're looking here is an example of 2 enabling functions, power and people. They were not there in that station. Power got interrupted and it was unmanned. Nobody could go and do a manual reset, and the station went down. Now, and I'll come to subsequent slides. You can take a step back and say, if this could happen to a station, the station can go down, which would lead to other impacts down the line. Can cyber play a role to effect this? And yes, there are methods by which cyber can play a role to effect this. This is an engineering consequence. This is on the ground consequence of what happens on the system. But how cyber can play a role to that. So we'll come to that. So vehicles of cyber sabotage. Cyber threat actors have an extensive collection of tools, methods, and resources to launch those attacks. So I'll speak to another slide on this particular topic. The likelihood of the breach being won. Now, this is where I was trying to speak that, assume that compromise will happen in your organization. Assume that you will be breached by an adversary, that an adversary has almost same knowledge as you about your technology. I'll give you an example, right? So this is a Dell laptop, right? Everybody has their own laptop. I can't say this is a Dell laptop for me as Prashant. Anybody can go online and you can look at the manual of a Dell laptop and you will know exactly all the bells and whistles which I know of running this technology. Now, as an industry, you're running certain equipment in your operations, right? You're running, say, the natural gas pipeline, a compressor station, running a GE turbine, or in a liquid system running a pump station, or Schneider Electric, or whatnot. These are standard technologies. You can't stop an adversary going and looking after the manuals and going and looking after all 9 yards to know how the technology runs. So the knowledge of an adversary would be similar to yours. That is something you cannot, they actually run labs. There are examples from intelligence communities that some of the enemy nation state actors, they run full labs of equipment which are running in our major sectors in North America, for example. and they exactly know the equipment, the version number, the firmware updates, and what you're running on your system. So that is also one thing we need to get away with, that you're not running any unique technology. There is a uniqueness, which I'll come to another slide, what you are providing in your systems and your processes, but the technology itself and the knowledge and the information is the same. That is not changing. The adversary is not limited to network-based attacks, right? So when you're looking at cyber, you're not only looking at just the packets going through the wire. You're also looking at supply chain. You're looking at contractors or people who can be disgruntled or who can bring in malware. You're looking at the people side, the vendors side, right? The SolarWinds attack, I have a list like going in the future, right? It was basically going after your vendor, and that vendor is so pervasive in the organizations, you don't have to directly go after the company. You go after the vendors and who the company does business with. Another quick example. In industrial security, as I said, Siemens or GE, or Emerson, I don't have to go after a particular company. I can go after that vendor. And as long as I go after that vendor and I sabotage or I create some kind of a malware in their system, and imagine the amount of equipment being used in all other industries of that particular model or even that particular manufacturer. And that's probably a larger way of impacting organizations rather than targeting a particular organization. So those are some examples where adversary is not just, there is this mindset that they will come through an internet, go into your business network on the IP side, then go into your OT side, and then try to break in and get your operations out. No, there are parallels out there. They can come in electromagnetic pulse. They can go into your field site, put an EMP gun towards your station controls, and they can take out your controls. Physical security, right? They can go after your wireless radio waves. They can go after the people side, as I said, the manufacturers. And those things are not pure network-based cyber attacks. Those are different ways of coming into your organization. Misuse of technology, so as I said, is one of them, right? Living of the land techniques. So misuse of technology will impact your critical functions. As I said, these technologies are there in your environment. And I also said that imagine the adversary is in your environment, knowing all what you know about your technology. They don't have to be different. Living of the land. Have you all heard of this term? So it's just like you are, or an adversary is acting like you as an administrator on the system. And they can run commands or do changes which are normally provided by technology for that technology to run. Again, Vivek said in the morning, and I'll speak to that. In the Oldsmar incident in Florida, they went in and you can change the set points of a chemical going into the water. That's a function provided by an HMI software on an HMI workstation. Nothing different, as long as you have alarms, those are, you can alert upon them, but the capabilities are provided to you. So you're not looking at something totally different for an adversary to come and do. They can do and mimic exactly what an administrator and a system will do and how they can impact you badly. So keep that in mind, as misuse of technology can go to an extent where they can have an adverse impact on society. A beautiful example of misuse of technology, the Ukraine crisis 2015-2016, when Russia attacked them, right? The UK Negro is their electrical company. This is the one actually being attacked right now. Russia is shelling them in their substations. Sandworm is actually one of the APT actors from Russia who were thought to be who infiltrated them. But the idea was, it was nothing unusual. There is a YouTube video if you want to ever Google and check it out. Literally, the technician on the station is calling the IT help desk and saying, my mouse is moving. My mouse's pointer is moving. Are you doing anything on my system? And that mouse goes in and clicks all the sub-relays of an electrical system, if you all know, and then it basically bypasses that and brings the station down. And so this is living on the land. They already have access. They are basically doing exactly what the technology allows them to do, and creating problems. Florida's Oldsmar incident, right? As Vivek said too, the HMI system, and they could have changed the set points on the waterfall. on the water system. So yeah, I saw this an interesting anecdote from Google. I thought I'll share it. Right, those who fail to learn from history are condemned to repeat it. It's Churchill. If we allow Ukraine to fall, then we have. Because we know some of these things, and this is not rocket science, which has happened in the past. We know some of the issues in the system. We know what consequences can happen. Are we prepared to run operations? Cyber resiliency, right? Ukraine is probably 30% down, as I probably heard from the president, in terms of their electrical capacity as they're being attacked right now. Can you be resilient in those circumstances? Did they prepare for that? A lot of lessons learned for future. But the idea is, let's prepare for those consequences which can impact you, and you still keep running your operations if you can enable your critical functions that I was talking about, even in the midst of attack, whether they're cyber, whether they're physical in nature. Physical could be harder, but there are ways to protect and prevent around that. Unverified trust, right? As misuse of technology is one vector, unverified trust. I won't go into all the details around it, but supply chain, third-party vendors. We talk about who has access into the environment. Do we trust a contractor, or do we trust a manufacturer's SME coming in, bringing their own contract, our own laptop, and plugging into the PLC of that particular turbine? All your network controls are basically gone at that point, because physically somebody has come in and they are looking and doing a firmware update on that particular turbine, which could bring the turbine down if that laptop has a malware. Did we have checks to make sure that that was not done? We have ways to understand what technology is coming into our environment, which people with intent are coming into our environment. Do we have any, firmware issues or software issues with the technology which are being brought in? So that's misuse of trust. Solar winds attack. I won't go into details again. This is one example where the sunburst malware was used, and it impacted a lot of companies. Led to DHS and CISA providing an update in USA that very, very important. You got to patch your systems from this particular update. Right? So what is the solution? For all this time, I've been talking about, Idaho National Labs, FBI. This is the methodology. Assume adversaries in your environment. Assume living off the land. Assume consequences are going to be there. So how do we look about as companies, as organizations, to go after solving this problem? Again, there's no solution ever of 100% to any problem. You always do your best effort to it. But which is where I said adversary would know what technology you use, the knowledge of it, so is you. So where are we different? Let's take a look. The defender's advantage. The perfect knowledge. The adversary will always know at least as much as you about your technology, maybe even more. But they don't always know how you use your technology to deliver a critical function. The understanding of how critical function is uniquely implemented at an organization, right? We have unique business processes. We have unique ways of using that technology. And for that matter, we have unique ways of creating our infrastructure. Take an example, you have again gas pipelines, say 2 gas pipelines going, redundant to each other, say having GE turbines running compressing the natural gas and flowing it through. That is unique to me. Another organization may have just one pipeline with one compressor station, same technology. I'm using the same technology, but I have my own designs to provide redundancy. I have my own ways where I know if this compressor station goes down, this one will take over. So I know my ways of delivering gas. I know my ways of delivering commodity or energy, and how I can support it and be resilient. And that is unique to you. Adversaries generally don't know unless they are within you as insiders about how you run your own operations. And that's where you need to find ways how you can mitigate those threats which an adversary can bring in, living off the land, knowing your technology, what can you do to stop them? And I'll come to that on how that could be accomplished. So that's the defender's advantage of you knowing more about how you run your operations with the same technology compared to an adversary. Consequence-driven, cyber-informed. When I say consequence-driven, again, we are looking at consequences first, more than we are looking at the cyber aspect of it. So methodology that guides organizations identifying and mitigating catastrophic effects resulting from cyber-enabled attack. We're looking at catastrophic events, right? Those subset of mission-critical functions If they go down, will lead to business going out of business or nation states having issues. So CCE overview. There are 4 phases to this methodology. I'll give some references in the end as well if you're interested in looking at it. Consequence prioritization, system of system analysis, consequence-based targeting, and mitigation and protections. In a nutshell, consequence prioritization talks about high consequence events. If you have heard this from low frequency, high consequence events, they happen quite less, but once they happen, they could lead to a failure, of operations. So we prioritize these consequences, and there's nothing cyber here again. You look and you talk to the engineers on the ground, you talk to the operators on the ground, the technicians, and you try to understand what are those consequences, and you make a list of those high consequence events. From those high consequence events, then we look at how is my system architected. You do a full documentation of access paths, people, process, technology, infrastructure, all the enabling functions which provide me those important critical functions. If they go down, those are my high consequence events. So you do a full lay of the land, understanding how your systems are architected and providing that, that function. Consequence-based targeting. This is from a threat actor's perspective. You are looking from outside in, that he knows about all your access paths in say number 2, and also knows what consequences can be, what would lead to high consequence events. Now I need to prioritize which of my consequences could be affected by a cyber event. Does that make sense? So this is more looking from a threat actor's perspective, how they can impact those consequences, because there could be 10 consequences, but not all 10 can be actionable. That is where a little bit of likelihood and prioritization comes into play. So keep that in mind. When I take likelihood being 1, that is more on assuming that breach will happen. This is more prioritization of consequences. Which one should I act first on my organization from an adversary perspective and try to fix those. And mitigation and protection. So I'll come to those. Finally, you find some of those stopgap measures, those engineering controls which can stop an adversary to impact. So that's the kind of understanding. You look at your high consequence events, understand your system, understand an adversary's perspective, how they can impact your system, and then what are your mitigations and protections to stop those high consequence events to become operational or come to effect. Another quick way of looking at it, more detailed approach, but I won't go into too much details around this. The idea is pretty much the same as I talked before. This is an important point I wanted to share with you all. So man in the loop approach, those who are process control engineers or those who know about OT security or industrial control security. This is Colonel Stanislav Petrov. You can Google him. He was the man who was credited to have saved the world in 1983. You can actually Google him. There's a documentary on him. He was a Russian colonel sitting in the missile control command and control system in close to Moscow, 1983, heightened awareness around Cold War. 5 alerts came in, high alerts that 5 ICBMs have been launched from USA towards Russia. And he was the duty officer at that time who was supposed to make a decision whether they were real events or false alarms and send it up the chain to the Army command and get an order to basically relaunch nuclear weapons towards the USA. And this guy at that time made a decision that those were false alarms. Imagine the scenario, the time, and you as a person at that time, and you have to make a call. You can't wait. Within 5 to 10 minutes, you would be obliterated, right? So one of his arguments was that they had a doctrine in Russian army that if US were to attack Russia, they won't do it in 5 or 10 ICBMs. They would do an all-out offensive on you. So that was one, he said, doesn't make sense that only 5 ICBMs have been sent. The other, he didn't only rely on the computer system, which actually he built or helped build with some of his other engineers, that this is giving me the exact data. So he went out and got confirmation from other sources on the ground, radar systems, Air Force, Navy, and said, do you see those things coming? And they said, no, we see nothing coming. So that was another feeler. And then he said, no, I think it's a false alarm. He's waited for 23 minutes, and he took a sigh of relief because that was the time from US to Russia. Within 23 minutes, the ICBMs would have come and operated the whole continent. And he said, lucky enough, I was right. Right? So the idea is about manual control. When you have these Google Nests in your environment, when you have this total automation going in, you're providing that automation to artificial intelligence or machine learning, you're losing that control. You're losing, still, I believe man is still, I think, the most intelligent machine still around. And you can make decisions which these control systems cannot. So make sure you have that control mechanism, whether it's a man in the loop, whether it's a safeguard of engineering asset, which I'll talk about, is important as you make those decisions. And not rely totally on the automation side. And I'm sure many of my OT friends out here or those who are in this field or engineers would agree to this aspect that, these systems cannot be fully relied on. You cannot automate everything to the T. You need to have some control, call it the emergency shutdown, call it the man in the loop who can make that call and break that loop, right? So very interesting study, take a look. And he got a lot of awards. He got reprimanded in Russia, by the way. Funny enough, he didn't put his war diary properly that day. So he said, I was on a phone and I was on another phone trying to talk out. I can't have 5 hands to really also make notes exactly what I'm doing at what point in time. And they reprimanded him because he didn't have good log of the war diary rather than saving the war. Lastly, the engineering mitigation and protections. So this is that mitigation protection aspect of this methodology. When we talk about automation, engineering, we talk about control systems, we sometimes have to take a step back and listen to engineers on the ground and say, guys, act like an engineer, think like an adversary. So you can think like an adversary. Vivek gave a very interesting example again in the morning. He said, if you have a fuel tank and the tank gets overflowed and goes out, you can create a pit around it where that overflow commodity goes and can still be contained and isolated. That's a simple engineering backstop or a backstop to somebody saying, I overflowed the tank and I was successful in basically breaking all the barriers and led to the overflow of the commodity and I did good to the system. No. Another example that Andrew Bachman gave was they did an Aurora test. If you you can Google that. An Aurora test was done in 2008 and 9, where a transformer was basically blown up. It's a YouTube video where DHS did a study. A transformer was blown up from remotely, and they found out with all the amount of dollars and efforts they put in that a simple wire bypass could have disabled that transformer. And so those engineering backstops, those walls which can be taken off, are examples which can reduce your impact on your system. This is physics. And physics can be used to reduce your impact to what can be enabled through digital means. So that's the idea. Engineering is built on immutable laws of physics, and that cannot be broken. You have a formula of how a chemical has to be put in. You have a formula of how gas turbine would run. So you follow your instincts on that aspect. Last on the summary, key concepts. The adversary is targeting critical and functions and how we deliver them. Don't blindly trust everything. The adversary may know what your systems are, but not necessarily how they're uniquely implemented in your organization. The defender's advantage of the perfect knowledge axiom. We have advantages that take the adversary years to acquire, and that comes back to our knowing of our systems and operations that we run. Always protect your data, but that is more on the confidentiality side. Again, I guess not to repeat the choir again, on the ICS side, we flipped the CIA triad for those who may know. Confidentiality, integrity, and availability is on the business side of the fence. On the IT side, where your privacy of data is probably more important. On the ICS and OT side, they call it the AIC triad. It's the availability, integrity, and then the confidentiality, which probably matters. But it's the availability of systems, the reliability and safety of operations, and running of those engineering artifacts, not the data around it at that point, which is more important for that operation. Key terms, won't speak them again, but I think I'm almost at the fag end of it. Some references here from INL, from the S4 conference, and this is the book if anybody wants to go and kind of get an idea on how this is done. And I have my friend Doug Lees here. He is one of our volunteers of B-Sides Calgary. He works with me in Enbridge as well. It's me in his space, a very nice guy. So he's offered to give us a practical example of how this would come to pass. So I'll give Doug a chance to.
If you want to take a look on the B-side,
Sure.
see if you can find it on YouTube.
Yeah.
Prashant and I had grand plans to actually put this together and do a live demo for you, but you'll have to come down to the CPF area where this will be going in about 30 minutes. So the video that
Try this 90-second trick to instantly
is
reduce your winter energy bills by 85.
You want me to get the video first, or you want to go?
The video's good.
Sure.
Yeah, the video's good. So,
5%. This jet engine.
now we can skip it. There we go. I wish I wrote that. Happy birthday. So there you go. You see this is a real thing. You can ignore the talking, but you're going to see that I go to a web page and we control this thing moving along. So this would be the equivalent of an HMI.
What you're looking at on the bottom of the frame is a motor control. But
Now,
no
the difference
Ethernet,
is that
no
there's no
Wi-Fi.
TCP/IP
The computer
involved in
controls
this at all.
comes through a custom signaling protocol.
We
with a
actually,
non-Wi-Fi
we
radio.
wrote a radio
You're
protocol.
patient.
Radio
If you
waves,
choose to
physical
accept it.
stuff, what could
To come
possibly
to
go wrong.
B-sides,
Radio transmitting,
21st,
it spins
They
this,
have
has
the
little
radio.
black boxes down there.
we'll have workshops on
And
how
you
to
can
convert Arduino
push your own
Raspberry
version
Pi
of the radio codes
into radio.
this way, and you can trigger an
You can
emergency
also
stop.
try your newfound skills
So
and any
that's fine, emergency
Or
stop
in
is safe. What
fact,
about
you
if
have
somebody's
or
working
real
on
live
the
test,
line,
just like the
doing
devil.
something, and you give it the backwards
Speaking of
command, it
DEFCON,
causes
This year,
break.
we'll also have village
So
IoT labs.
Prashant and I were talking about this, this was a
Let's
gas
check
compressor, for example. If you shut those things down too quickly, you break them. If you want to do one, you're not going to Home Depot, you're waiting 6 months. So that's kind of the consequence stuff that we were talking about in CCE is, I don't care how you broke it, I'm out of business for 6 months. That's the difference. So this will be live to come and play with, and, you know, we can even demo the emergency shutdown, all that kind of stuff. It was just a little much to try and get it working here because there's a bunch of paraphernalia hooked up, as you can appreciate. But the radio, there's some guys walking around here with these things called flippers. The radio to shut this down could fit in your pocket. So it's not anybody coming by to clean the bathrooms could shut your stuff down. It's a dangerous idea. And we use lots of radio and critical infrastructure. It's all over the place. So any path in is good. So I thought it was great talk, Sean. Thanks.
Yeah, thank you, Doug.
But yeah, come on by if you want to talk to the radio.
Any questions, by the way? Any comments, feedback?
Does this like overlap with the FUC certification at all?
FQC?
FUC, like the functional safety engineer from Germany?
No, I have not heard of that certification. Just to share on that point, so Idaho National Labs also has another methodology called Cyber PHA. That cyber process hazard analysis, for those who are in this field, process hazard analysis or HAZOP studies are done where they look at safety. So they do a comparison between cyber PHA, which is related to standards like IEC 62443, those kind of standards, and the CCE methodology. They both relate to consequences, how consequences can impact safety of systems. But that's more of the comparative analysis, if that's what you're moving towards. But not sure about that particular certification. Yes, go ahead.
What's your opinion on how Canada is doing in terms of hardening of critical infrastructure systems over the last few years?
So it's a work in progress. But I think in North America we do a better job compared to other geopolitical regions in the world, including America and Canada. America definitely takes the lead, in my opinion, because they have some regulations, they have more more effort in terms of people, process, technology, information sharing sectors, etc. But Canada is catching up. The Public Safety Canada is one of the arms, and they deal with this kind of regulation and safety of critical infrastructure. And interesting enough, I'm giving a talk in ICS Symposium next week, 25th of October, exactly on this topic from an inside the threat perspective. So yeah, there is information sharing, gathering, regulation, which is playing a role, but it all comes down to awareness, right? And ultimately, what companies see is important for their operations. And so it's a public-private partnership. You cannot put the onus on one or the other. It has to be informed on both sides. U.S. is taking the lead, in my opinion, because of the attacks they have had on the Colonial Pipeline and whatnot. Canada is there. Australia, New Zealand, UK, they're following behind, the Five Eyes of the world, as they call it. But a lot to learn, because the world is changing. If you see it a little bit differently, these systems run out of life: water, gas, power, right? And if they run out of life and they get impacted, it drives back home a very important point, that what are we doing to secure them? Yes, Vince.
So when you engineer your control strategy or PNID, how do you put a human factor in the middle?
So I would say, from a CCE methodology perspective, those mitigations and protections, which was the phase 4, many organizations actually go from phase 1 directly to phase 4. They say, why? I already know my consequences. I can put in my protection. Why do I need to go a system analysis and figure out what an adversary is going to do to me? I know my consequences, I'll do that. So I would say in the mitigation section, where, again, depending on control systems, but that human engineering knowledge, whether it's an HMI technician on the ground, he can look at those controls, those set points. Do we have business processes around that? Technicians are doing firmware updates. Do we listen to them and their feedback as they bring it on, right? Or we are just saying, or overpassing their knowledge. That will stay and should always stay. That understanding of the engineer's perspective and knowledge of the system, and listening to them would stay. And we, I think, honestly enough, are still learning how to move from the IT security to the OT security side, and what it even makes sense at that gray area and the gap between the two. And so, it's a work in progress, but I certainly believe, many times on that point, they say this methodology, as Andrew Bachman says, go back to legacy control, because we're bringing in a manual intervention here. We're bringing in engineering back here. So we're not becoming more digitally enabled. We are rather going back to ages, but that's not true. And even if it is true, I would rather have an analog phone in the Armageddon, right? I can talk to somebody rather than having a Rogers outage and I cannot talk to anybody. So it's how you bring your system and be resilient. And honest enough, if that works, because communication is important. So it's that mindset. So I would still say the role of a manual control, the role of analog, the role of engineering controls would still remain to reduce that impact, however much digitally enabled or cyber enabled it is.
Thank you.
That helps you to understand the severity of the impact.
Exactly. Yeah. And this is exactly the point. Look at consequences, how it's going to impact you. What are you doing to try to mitigate it? You can have all 9 yards, all different mitigation. Thank you for being a patient audience. Really appreciate that.